Today's presenter is Lucidworks co-founder, senior solutions architect, and Solr committer, Erik Hatcher. Thank you for joining us today, Erik.
Thanks, Aaliyah. It's good to be here. Today we're going to be talking about a feature of Solr that came along around Solr 5.2 and has evolved a bit through the various 5.x releases. First, I'm going to review a couple of previous technologies that make this whole thing work. That's the bin, post, and browse. So first, I want to mention that this is based off of a trilogy of blog posts that I worked on, and the first of the series of blog posts was about bin post. Bin post is a tool that was introduced with Solr 5.0 to allow easy ingestion of your data into a Solr collection. The bin post tool, currently only a Unix tool, allows you to, from the command line, to post CSV, XML, JSON, and various rich document formats such as Word, PDF, HTML. And it does the right thing by picking up on the document type and sending it to the right endpoint in Solr. So it's effectively a lightweight client to Solr's update handlers, so both /update and /update/extract, and also moving forward the JSON one to be able to get rich JSON documents into Solr as well. And there's the pointer on the slide there to the first in the series of the blog posts about the bin post utility. Getting data into Solr wouldn't be much fun unless we could actually visualize it. So along came the next in the series of the blog post trilogy there, and that is about a facility in Solr called /browse. /browse has been in Solr for quite a while. It is powered by a templating technology called Velocity, which is another open source Apache project to allow templating of really anything, as long as you can put data into a template context and tell it to render. The /browse facility in Solr is a request handler that leverages one of the Velocity response writer in Solr. This allows the Solr response to be presented in a textual way, not necessarily in a data format way, in just a textual way. So it doesn't have to be HTML, but what we generally emit from a Velocity response writer is an HTML response to be able to have a user interface. And so in this blog post here about the browse facility, it describes what makes it work. It describes the various context objects that you have, what's called tools, so that you can do data, you can format numbers, dates, and escape HTML and URL strings and so on. So there's a lot of useful and necessary facilities inside of the Velocity response writer's context to allow you to richly template what you need. And in that blog post, you'll see examples of how the generic browse facility works. So in the latest versions of Solr 5.x, you can post your data in and then just go to the /browse URL of your domain, your data-driven configured collection, and get a generic user interface. And you see a bit of that at the bottom of the screenshot on the slide here, where there's a text box, a submit button, and then just standard results there that allow paging through the results. If there were faceting parameters added, you would see the field facets on the left column of the UI and be able to navigate that way. This is a general purpose user interface that, again, comes with the data-driven config set that ships with Solr 5. And so this has been and it also has some nice debug facilities in there so that you can look at all of the fields of a document. You can look at the scoring explanations from the relevancy computations and how the query is parsed. All of those, that debug information is made visible in the user interface when you click the debug link at the bottom. Okay, so that's two different things here, getting data in with bin post and then visualizing it with /browse. We wanted to take this one more level up and wrap this up into a cohesive domain-centric example of getting data in and presenting it. And the domain that we opted for here was a straightforward document, rich document facility, allowing you to very easily, again, bin post your file into a Solr collection, and then have an enriched user interface experience that's a step up beyond the generic browse that comes out of the box with, again, with the data-driven config set. So in the example files configuration, you get several value adds above and beyond the general purpose bin post and browse. You get a document type navigation, and these are distilled document types. We'll go into this in just a moment, how that works. There is a multilingual and localizable interface, currently localized into English, French, and German. And several other features in there. We do, at indexing time, language detection, and then at query time, faceting on the languages. So it will detect the type of the language of the content itself from each of the documents and tag each document as it's being indexed with the language that's detected. We also have a facility in there to extract phrases, also known as shingles, and index those and present those into a tag cloud-like interface so that you can see the popular phrases that are across a set or subset of your documents. And a couple of other interesting things in there. We also extract email addresses and URLs from the content as it's being indexed, and we'll talk a bit more about that as well. Each one of these features we're going to detail more. And then there is the instant search. This was because we took a UI-centric approach. We wanted, as you type, search results to appear. Okay, so all of those things are above and beyond the general purpose built-in browse experience, and built this into example files. Example files is a literal directory reference. So in your Solr distribution, there is an example directory, and then there's a number of subdirectories under that, and files happens to be one of them. So if you've got a Solr 5X install around, look into your example directory, look in the files directory, and there is a README file there that will guide you on how to get started. But to cut to the chase here is the quick start for example files. Start Solr, you create a collection. Now the secret to getting the example files configuration instead of the default data-driven configuration is to use the -D switch on the create command. That tells it to use a different directory for the configuration. And you can simply say example files, and it'll pick up on the Solr specific comp subdirectory structure of the example files directory. And then simply bin post your files to the collection that you created. In the example here, we created a collection called files. You'll see -C files. And then we've been posted to -C files as well. And we're posting all documents recursively through the my home directory, the ~/documents directory. And then finally, to get the file-centric view, we go to the URL /Solr, and then to the files collection, and then the /browse request handler under that. Okay, so that's the quick start to having your own file search engine. Now, one of the driving forces, or one of the motivators that we kept in mind as we built the example files configuration was that we wanted it to be driven by the domain and the user interface. Not about the data first, it's about the user experience. And that's something that often is overlooked or given not as much importance in the application building area. And taking the front-end first perspective forces us to consider how to make things like the UI easy to use, and it drives the types of requests and the types of configuration that we need to build the application. Rather than taking it from the data up into the configuration, into the request handlers, and so on, we wanted it to be driven from the view backwards. And in this case, it's a traditional search user interface here. We have a search box. We have results displayed with the file name and some highlighting information when it matches the query. And then at the top of the search results, you also have this type navigation. On the side, there are top phrases that were extracted, and then the languages that were identified during indexing. So all of those were put at the forefront of our design for this, and we're going to take a look at each one of these features going backwards down into the Solr configuration. And we're going to get into some hairy configuration and some neat Solr tips and tricks as we drive backwards from this user interface. So the first thing that we did was distill document types from the content as it was being indexed. And you'll see the details of this in a moment. We determined a handful of high-level types, HTML, image, text file, PDF, as the top-level groups of types of documents. And during indexing, we distilled the rich MIME type or content type of the content down into a small subset of these types that we show in these navigators at the top of the results. And on the right side of the UI are top phrases. These top phrases, it's still a work in progress. It's more of the concept of the thing than the actual implementation. So certainly this is one of the to-dos that we have moving forward, is to enrich the types of phrases that are extracted. It can be a little awkward to see it in its current form, but sometimes it will actually extract some useful phrases here. And actually, all of the phrases that you see in this screenshot are distilled from an image file. There happened to be enough metadata in the image file that gave some reasonable phrases. And then we have language detection and faceting. And again, just traditional faceting here, but the language was detected using one of the two different types of language detection components built into Solr. And also on the user interface, we wanted to leverage localizability and be able to have the user interface, all of the standard text strings, hard-coded text strings that were in the user interface, be localized. And we have the ability to toggle with the globe icon in the top right of the user interface between English, French, and German. And all of the text strings that you see, even the file type navigators, the headers to the facets, the word find, and the header, the title of the whole page, have all been localized. And this is a facility of the Velocity Response Writer that has Java resource bundle capability. So we leveraged a standard Java feature and surfaced it through a resource tool inside of the velocity response writer templates that are being used here. Not only is the web page itself the user interface, the URLs are the interface as well. And in fact, they're the user interface. The user often would manipulate the URL and change parameters in the URL. So we wanted that to be as clean as we possibly could. And we are a little bit constrained in this environment. In fact, we're a lot of bit constrained in this environment because the requests, even /browse itself, are going directly to Solr. So Solr imposes rules and parameter names and so on the parameters that are available there. But there's a lot of flexibility in how we can indirect parameters. We can wire things into the configuration such that there are parameters that come along implicitly with /browse, as well as so a lot of things that can come implicitly with /browse, and ways that we can take cleaner parameters that are user-centric and map those into maybe the more obtuse or Solr-centric names of parameters underneath. And we're going to start seeing how we achieved the nice UI and the nice URLs, leveraging some very sophisticated features of Solr. So I'm going to start drilling into that as we go here. But first, let's take a look at some of these URLs here. So if you want to browse by a particular type of file, just your PDF files, it's just /browse type equals PDF. Again, there's a bit of mapping that's going on here. Type is not a parameter that Solr knows about. It's not leveraged in any way from any Solr component, but we have some indirection mechanisms in the configuration. And again, we'll take a look at those in just a moment. Likewise with localizing the interface, because the parameters are, because the /browse is a stateless URL, we have to pass the parameters that the user is selecting onto the URL. So when the user selects locale, we add that to the parameters. And another interesting aspect of adding type and locale to the parameters are that those also get maintained on future links that are in the page. So if the user changes the locale to German and then subsequently picks a language facet for the language of document or a particular type, we retain the fact that they are in German locale and carry that along for future requests that are made. So there's a fair bit of templating infrastructure in place as well to carry along, to keep any parameters, keep special parameters on the URLs. And just to show you how we've gone from, how we've made the URL simpler, just wanted to do a little comparison here between /browse and what generally folks use with Solr as /select. First of all, /browse. There's nothing special or magical about it. It's simply a request handler definition in the Solr config XML file. There's a lot of parameter wrangling that happens within that configuration and the paramsets that are used to make this work the way that you see. But you can make effectively the exact same request to Solr using /select and handing it all of the parameters that are otherwise implicitly defined or user specified. And let's just take a look at that. So on the /browse side of things, /browse takes care of all of the parameters that you see in that bold section of the /select aspect here. So it sets the writer type to velocity, it sets the template, the layout, defaults to *, and * to match all documents, and it has a lot of faceting stuff turned on, a lot of parameters that just get carried along for the ride as part of that /browse definition. That's not atypical. That's a fairly typical scenario where a user will define a custom request handler and bake a lot of the parameters into that request handler. Now, how do we achieve things like this type equals HTML? You'll see that translates into a little bit of an ugly SQ parameter here, where we're using a custom query parser, a field query parser, and we are querying the doc type field for the value of HTML. So there's a bit of translation and parameter substitution that's going on to effectively build that FQ from an outside type equals HTML. And likewise with the locale parameter here, there's not a big difference here, but we wanted to hide the fact that we're using velocity per se and simply have a clean parameter from the outside that specifies what the locale is. On the inside, from the velocity response writer perspective, the parameter to control the locale is through a parameter called v.locale. Okay, so that's a lot of magic, a lot of stuff that's going on there to achieve these clean URLs. And what I'm going to do now is detail a bit more of the inside that makes that work. Okay. Before we get to those specifics, let me just call out a number of the tips and tricks that are occurring and that we can call out inside of this example file. It looks nice and clean from the outside. That was the goal. But to achieve that, we had to understand Solr's parameter mechanism and the indexing update processor mechanisms, and to be able to build these higher level features to make it look lean and clean and simple from the outside. So let's make this a little bit more of a expert level Solr presentation moving forward, and let me show you how we achieve things like the indexing pipeline, where we detect the language of the document, how we distill the document types from the richer, more nuanced MIME types that are identified when documents come in. I'll show you how we extract email addresses and URLs from the incoming text. And I'll show you the tricks that we're currently using for the top phrases extraction. And on the query pipeline side of things, there's not a lot that goes on other than the tricky parameter substitution and some other query parser tricks that we use on the query side of things. And then on the UI side of things, the localization, that's another one to call out to show you more specifically how that works. So first, our first look at some configuration here. The language detection is turned on using the lang detect update processor. There is another language detection update processor available in Solr based on Tika. I just happen to choose this particular one to wire in there. In fact, I may actually augment this to choose to have both of them wired in there so that we could compare and contrast the detection through two different types of detection algorithms. The configuration that you're seeing here, and I'll just mention this while we're here, is a little bit different than what you'll see in the released version of Solr. As I was preparing the final blog entry and this webinar, I wanted to fix a few rough edges in here, so I added the lang ID fallback, and I upped the lang ID threshold to get a little bit better language detection in there. And there was a couple other minor tweaks that I've made, and I've actually pushed these to a patch in a Solr issue tracking system. So these will any little fixes that I made here will make it back into future versions of Solr. And I'll call out the tweaks that I made and the ticket that has those patches on it in just a moment. Don't feel compelled to have to read this JavaScript code that's on the screen right now, but this is the section of the update script that identifies the document type. And we're using the content type field that comes in from the extract handler. So when say a PDF file gets sent into Solr, the content type is identified. There's different mechanisms for it heuristics used to identify the content type, but Tika will identify a reasonable content type and give it to you as image/JPEG or application/PDF in true MIME type, content type fashion. We do a few things in here. We actually break the content type into the type and subtype. We add those as fields. We don't really leverage that, but they're in the user interface at the moment. But the image is one field and JPEG is another field, is type and subtype. We also take the content type and pass it through a set of conditions, a set of regular expressions to see how they match against certain patterns, and then we break out the high-level document type from that. So maybe you can see in the code there, the first switch case statement there is looking for image/star and identifies anything that has an image type in its content type is an image document type. For presentations, we look for presentation or PowerPoint and so on, and then we have these high-level types there. So we get doc, HTML, text, spreadsheet, and PDF. Those are the high-level types that we currently support in there. If it's not any of those, then the document will not have a doc type field assigned to it. Only one of those 5 values will be present on the document, if at all. Okay, so that is accomplished through a JavaScript update processor. So we have a custom tailored update processor chain defined in our Solr config. It's got the language identifier in there, and it's got this update script wired in there as well. And there's a couple of other things that we achieve in that update script that we'll see in just a moment. Okay, and there's a lot of stuff going on this slide right here, but this is the secret sauce, I suppose, that extracts email addresses and URLs from incoming text. Now, let me back up for a second. We can do email and URL extraction and indexing using a field type in Solr and having it be an index field. If we do that and we copy field our content into a field that filters out just emails and URLs, then we will have indexed emails and URLs into a separate field. However, we will not have those emails and URLs as stored values on the document. And that's a big difference. And so one of the goals here was to be able to extract the email addresses and the URLs into a usable fashion, not just for search, but for retrieving. So if I'm looking at a document, I want to see on that document all of the URLs and all of the email addresses that were in the content mentioned. So the technique used here is specifically designed because we want the values to be stored and leverage the analysis techniques that Solr offers. So with that, we defined a field type, nothing earth-shattering or new about that. We define a field type. We leverage a couple of pieces that you may not have seen before, we leverage the email tokenizer URL, email tokenizer factory, and that will tokenize the text and tag the emails and email addresses and URLs as such. And then there is this type token filter. And I'm going to illustrate that in more detail on the next slide. But that's the definition there. And it points out that type token filter points to a separate text file, the email URL types.txt file, and it contains literally what you see there with brackets and all. And I'll show you again in a moment how that field type works in more detail. Now, the script that you see at the bottom of the slide there is in the update script, just below the part that identifies the document types. And it leverages this field type definition, runs the analysis process on the content, extracts just email addresses and just URLs, and sets them as stored and indexed field values for the document. So kind of a lot going on there, a fair bit of complexity there, but that's what it takes to leverage Solr analysis and feed that back as stored field values. Hopefully that made sense. I did explain this a little bit more on the blog entry that accompanies this webinar, basically. And this slide right here is meant to illustrate how that text email URL field type works. And we're leveraging the, I used the admin tool of Solr, the analysis tab in there, to use, to put in some arbitrary text. You can see my email address at, literally the word at, and the Lucidworks URL. And I analyzed that text using that field type definition that you just saw. And what you see in the output here are the results of each of the analysis steps. The first one is the tokenizer. The tokenizer chunks the email address as a single unit, and then it chunks out the word at. So you see that in the top line there of the results there, where it's got my email address and then the word at and then our URL. So there are 3 tokens that come out of that first step. Now, all we want are email addresses and URLs. So what you can see there also is a row that says type. And that type row in the first section for the tokenizer is email, alphanum, and URL. Again, all we care about are email and URL. So the next component in that analysis chain is a type token filter. That type token filter has a whitelist of types that it allows, and email and URL are the 2 types that it allows, and thus the alphanum token is omitted in the final result. So that bottom section that you see on the screen there are the 2 tokens that would come out of analyzing that text. And those are the 2 pieces that we want to actually set into a multi-valued stored and indexed field, and that's what that previous script accomplished. Okay, so that's kind of a lot of sophisticated Solr trickery there to achieve that higher level goal of extracting email addresses and URLs. And you know, one of the aspects of this example file is, again, to be an example, to show how some of these features that you haven't normally seen in Solr configurations shown in a way that is useful in a domain-specific way. This URL and email extraction is one of these semi-hidden features in the example files. We don't surface this yet in the UI. However, and in fact, there was a bug that I determined as I was creating the materials for the webinar and the blog entry where the brackets were left in the field name. So that is a fix that I've made as well And then you could see here on this slide here at the bottom what it would take to actually see the emails and the URLs extracted from that. And you can see that I'm using a dynamic field type suffix, the _SS, which is a multi-valued string field. And I use the token type as part of that field name. So you'll see a little bit of funny business in there when we add the field to the document, where it does a replace and gets rid of the angle brackets, lowercases it, and then appends the _SS to both the URL and the email address fields. Okay, and now moving on. This is the configuration to extract what we call top phrases. As I mentioned before, this is still a work in progress. This is not super refined. It illustrates some interesting features of analysis right now with the pattern replace and with the shingle filtering going on and so on, as well as what to do with query time considerations when at index time shingles were made and so on, because we don't need to shingle the query itself. We simply use the keyword tokenizer factory in lowercase the query terms for query time parsing. So we have a field type. We have a field text shingles. You see that in the lower right section there. And then we have a copy field where we copy the content into the text shingles field. The text shingles field is not stored, but is indexed. So all of the shingles, all of the phrases that come out of that index time configuration for the text shingles field type are the indexed terms on the document. Now, this is, maybe I should have shown this one before the email address and URL extraction. Two different types of scenarios here. With the top phrases, we chose to only index those phrases and not have those stored. So we could leverage the more traditional copy field approach here to allow just index time capabilities there on the phrases that are extracted. Whereas with the email and the URLs, we wanted those to be stored values. So again, by example a little bit here, so you could see the two different ways of using analysis to extract something interesting and also potentially store that extracted goodness back onto the document. Okay, moving on. Let's talk about the implementation of document type faceting and filtering. There's a lot of interesting Solr trickery that goes on to make this happen. And these parameters are baked into the /browse and the Paramsets that the /browse handler refers to. And that's yet another interesting feature that I'll call out there on the configuration. But I've unwound those parameters from XML and JSON configuration files and just kind of showed them in line here. So to facet on document type, on doc type, facet.field doc type, you'll see that there is this curly bracket exclamation point EX. That is for faceting exclusion, and I'll go into more of that in just a second. We also want doc type faceting to show you zero counts so that you still get a header in the navigation for particular types that have no values there. So they may be they are in the index, and there are some documents that have those doc types. They just don't happen to be in the current result set. So you filtered on a language that doesn't have doesn't have a particular type of document, say an image. There's 0 images that are in Norwegian, for example, but you still are going to see a 0 count for the image type. We also turn on facet missing so that we get a count back of the documents that do not have a doc type at all identified. And we actually show this. The screenshots in these slides don't show this, but if there were document types that were not identified or identifiable through the regular expressions that we match, then we show unknown as a type in the type filters in that search results header, and you can click on that and filter down to documents that do not have a type at all. So we have that mode in there as well, and that parameter facilitates that feature. And there's one other tricky thing here about faceting on doc type. We want also for there to be a special type or navigation available for all types. And we achieve that by using the facet.query technique. The facet.query allows us to provide an arbitrary query, star colon star in this case, so all documents. And as you know about faceting, when you facet this way, you're saying not necessarily all documents, but all documents within the current query and filter scope. So within the result set, give me back a count of all types of documents there, all doc types. So that's the tricks that we use to show all type counts, unknown type counts, and then also we have this exclusion thing. So that exclusion allows us to exclude the current filter for doc type. This allows us to show counts for the other types even though we're filtered to a specific type. If you simply use field faceting and then filtered, FQ'd, down to a particular value of a field, the facet values that you get for that field now become 0 or not available if your min count is 1 because you've narrowed down the scope. So this exclusion allows us to exclude one filter from the counts available for the doc type. So this gives us the ability to keep the count even though we're filtering along the way. Now, how do we define that type? So where you say EX equals type there, that keyword type maps to where you see in the bottom right box here, you see tag equals type on that FQ. That tag equal type tags that filter with a particular keyword, type in this case, and it is what gets excluded from those other faceting options. Now, that FQ, that's an interesting one. There's a lot going on there. That's a switch query parser, so the curly bracket exclamation point switch says use the switch query parser. The switch query parser keys off of the value of $type. That is a param substitution indirection. So remember our URLs say type equal doc or PDF or image. It switches off of that value. If there is no type parameter submitted on the request, that top case, the default case, star colon star is used. So all types are shown. So filtering FQ equals star colon star effectively, which means no filtering effectively. If type is equal to the special word all, then we also use star colon star. If that value, the parameter type, is the special value of unknown, then we exclude all documents that have a doc type. So we have a special Lucene type query here that says minus doc type colon star to star. And that is a special type of query that says match all documents that do not have a value indexed in the doc type field. We can now filter on all unknown typed documents. If, however, there is a type value specified, and it's one of these doc, PDF, image, etc., then it goes to the default mode of that switch query parser and picks another parameter called type FQ. So you can see the $ there is a parameter reference, and it pulls in the value of another parameter called type FQ here. And that type FQ is a straightforward field query. So we're leveraging the field query parser. You may not have seen that one either, but that's a pretty handy one to narrow the query parsing down to just a particular field and just a value. And the value again here is indirected with that $ type. So it pulls in the parameter from the outside, from the browse URL that the user clicked on that says type equals PDF. So that gets substituted in there. So again, a fair bit of little magic going on. Okay, so let me just kind of wrap up the gory details here, and then I'll get it back over to questions in just a moment. So here is the definition of the browse handler. The browse handler pretty much indirects all parameters through a feature called Paramsets. This is a new feature in Solr 5 that allows parameters to be defined in a separate configuration file. That also means that there actually also is an API for Paramsets that does not require a core reload, so it's a very handy feature for being able to adjust parameters dynamically. And you can see all the various parameters that we've illustrated being spelled out here in those various ways. And I'll just call out the very last one there on the bottom right, the v.locale. That's another technique here that indirects using parameter substitution in a slightly different way, the outside parameter called locale into the velocity response writer specific parameter called v.locale. Okay, so there's kind of a lot going on there with the configurations, all to achieve that kind of external simplicity there. I've crossed out a few things here on the what's next because I just fixed those as I was building these slides and demonstration out, and we'll get that in the next Solr release. And then there's a whole bunch of other kind of wish list items there to do and improvements to be made there. And real quickly, as I'm wrapping up here, I'm actually going to write this up as a follow-up blog that builds upon the trilogy here and this example files that leverages Lucidworks Fusion to add in some interesting capabilities into what we call what we kind of lasso as a real application. So we think of example files as your Solr-based application, and keeping it as a Solr-based application, you can add in various things like analytics. So we can add into example files very easily the ability to log queries, even the as you type one. So both of these graphs, top graph shows as you type, it's being logged, every character that you type as a separate log item. And we can filter those out. And you can see that in the bottom part where we exclude the instant search as you type queries, and then only show you the queries that were hard entered by the user. So we have both of those types of analytics that are easily possible here. We can add in landing pages. So here's an example here where I leverage the Fusion landing pages to be able to match what the user as they're typing and provide the landing pages as see also links within the UI. And those are the value adds there. I will take a deep breath here and pause and see if there's any questions.
Great. Thank you, Erik. So we'll now begin the Q&A portion of the session. Again, if you have any questions, you can enter them into the chat window on the bottom left of the screen. So Erik, the first question we have for you today is, Is it better to store the extracted text in a multi-value field as opposed to maybe a pattern tokenizer factory field with a separator?
That's a good question. I'm not sure I fully understand, but it's really up to your application and your needs. Do you need the text to be stored and available on the documents themselves, or do you need the extracted values to just be searchable and facetable? And so the techniques that you use for extraction is going to depend on what you want to do with that particular text. Okay.
Okay, thank you. The next question is, can language detection work on queries?
Great question. That is something that I did not explore with example files. And the language detection in this case is only being used to tag the documents of the language. It's not being used, and actually it's capable of doing this, but I didn't leverage this yet, is to filter the content to separate fields so that you have language-specific fields. Right now, all content goes into a content field, and that's it. It just happens that language of that content is identified. We're not leveraging it in any other way. But identification of a query, I've heard that that's a very difficult thing and not really that possible. And generally, different approaches are used to fan the query terms out to multiple fields, various language-specific fields, in that manner. That's all.
Great. Ready for the next question?
Yep.
All right. Next question is, are there any new facilities with Solr 5.x that will help speed up indexing of data stored in MySQL?
Totally unrelated to this presentation, but I don't believe there's anything special. I mean, the Solr has the data import handler, and there's some tricks to do that sort of thing. If you are indexing from the outside and have the ability to, select parts of your database and index it in parallel, various parts of it, and you can speed up that way. Yeah.
Thank you. Next question. Are there plans to make bin post available on Windows?
Yes, there are, and I thank the asker of the question for volunteering to create such a facility. I'm a Mac Unix person myself, so when I created bin posts, I did it, the only way that I really could was with the facilities that I had available. Not being a Windows person, I filed a JIRA that says we need a bin post in Windows format, so I'm really just kind of waiting for someone on the Windows savvy side of things to contribute such a thing.
Thank you. Can parameters such as update chain be passed to Solr /update through bin post, aka simple post tool?
Yes, it very much can. Parameters can pass through bin post with -d update.chain, I believe, should do the trick. There is a facility to pass parameters through, but I think that's the right way.
Next question is, how do you secure your Solr application? Specifically, any user who can query also can modify the data. How can it be restricted?
Thanks for the commercial plug. I would say the answer is Lucidworks Fusion. That's not necessarily a snarky reply, but yeah, so Solr is wide open effectively out of the box. So if you have Solr running locally on your machine, you can add content to it, you can query it, and you can then subsequently delete content. So it certainly can be challenging to lock those down. People have come up with various solutions, from tweaking the configuration of Solr itself, not recommended, to putting proxies in front of Solr, which is a pragmatic way to do that sort of thing. And effectively what Lucidworks Fusion does is put a secured proxy in the middle. That's the answer I got.
Great, thank you. The next question is, can you summarize the best way to use analytics out of the box and any tools around this?
To leverage analytics out of the box. So, I mean, that's a little bit of a segue back to what I'm actually showing on the screen right now. The way that these graphs were generated right here were by adding a plugin into my own application, Solr config. So in example files, Solr config that says point to Fusion as for logging. And so every query that comes into Solr is subsequently logged to a Fusion or to another Solr collection. And then Kibana, our Solr port of Kibana, called Banana or Silk, is what is drawing these graphs right here. So there's various ways to do it. I would say get your analytics data into a Solr collection and then point at it with Banana, and that would be analytics for you.
Thank you. This will be the last question for today's session. Can structured data from a database be indexed with extracted text? Are these techniques only valid for free text?
Good question. That is certainly a tricky scenario when you're coupling and trying to merge two different data sources, zipper them together effectively. The Solr's data import handler allows for a very rich, sophisticated way of connecting multiple data sources together to build a single document for Solr. So with data import handler, if I was indexing database content with this example files, effectively, if I had a data import handler in there, I could have a database that points to, say, PDF files, and the data import handler would index the database content, metadata, and then reach out to the PDF file, extract its content with the same facility that Ben Post does to extract the Tika capability, and fold that content in on the data obtained from the database and present a single holistic document of all of those fields as a single document to Solr. And so, yes, the same language detection, update script for document type detection, extracting emails and URLs and all that sort of thing would still work in that case. You would not use Ben Post. Ben Post is straight up external data files going in. It doesn't do any kind of merging like that, but the data import handler could do this, yes.
Great. Thank you, Erik. So we are just about out of time. Just so everybody knows, anyone who registered for this webinar, whether they were able to attend or not, will receive a link to the recording shortly. If you have any questions, feel free to reach out to Lucidworks. And if we did not have time to answer your question on today's session, please look out for a note from someone on the Lucidworks team shortly. Thanks again for joining us today, and we hope you enjoyed the webinar.
Thank you.